Hello, welcome to my class. In this class we will solve some multiple choice questions from applications of trigonometry. And these multiple choice questions, I will give you some examples of these questions as well as the concept. And the concept to solve these questions is like we will use some basic trigonometric ratios like sine, cosine and tangent. And we have learnt about a mnemonic which is used to remember these ratios, that is popularly known as SOHCAHTOA. And some people know it by the name Pandit Badri Prasad Har Har Bole also, but I prefer using SOHCAHTOA because I sometimes get confused while using Pandit Badri Prasad. Now let me explain this mnemonic. This means S means sine. Sine is opposite over hypotenuse, and this tells us about cosine, and this is adjacent over hypotenuse, and tangent is just opposite over adjacent. Now what is this opposite, adjacent and hypotenuse? See, as we have already discussed in our previous videos, that trigonometry is all about triangle measurements. Okay, so and we are talking about right triangles here. So let us say this is one of the right triangles where this is a right angle, 90-degree angle, and this is the angle theta that we are talking about, for which we will take sine, cosine and tangent. So if we are talking about sine of theta, then this is the opposite side. Let us say this is x, this is y, and this is z. So sine of theta will be equal to opposite, that is x, divided by hypotenuse, that is z. And cosine of theta in this triangle will be adjacent is y, divided by hypotenuse, which is z once again. And tangent of theta will be equal to opposite is again x, divided by adjacent, that is y. So this was about mnemonic. Now in this is opposite side when we are talking about this angle. Okay, this is opposite side, this is hypotenuse, and the third side will be adjacent side. Alright, and why do I get confused in that Pandit Badri Prasad Har Har Bole? Okay, let us take a right triangle once again, and let us say this is angle theta which we are talking about. Again, take the same measurements x, y and z. So let us take sine of theta. It will be perpendicular by hypotenuse. Now perpendicular is x and hypotenuse is y. Alright, but in case I take this angle theta here, and now I have to take sine of theta, what will be perpendicular now? Is this the perpendicular side or this is the perpendicular side? So sometimes I get confused in these So I prefer using So-Katoa rule, and this was about this mnemonic, which we will often use while solving multiple choice question as well as other questions of trigonometry. Now, there is one more thing which I want to discuss. Okay, and that is about two particular kind of triangles in trigonometry, where we will use geometry results to solve multiple choice questions. This is a right triangle with one angle 30 degrees, and then the third angle is 60 degree. In these type of triangles, there is a particular kind of ratio which can be seen in every triangle which is 30, 60, 90 degree triangle, and that ratio is 30 degree, 60 degree and 90 degree. The ratio of sides opposite to 30 degrees, 60 degree and 90 degree will be always 1 ratio √3 ratio 2. I can derive this result. Okay, you don't have to memorize this result without logic. Okay, I have constructed an equilateral triangle. Let us say this is an equilateral triangle with sides x. In an equilateral triangle, we have all the sides which are equal, and the angles will be equal to 60 degrees, and let us say this is a perpendicular which we have dropped, so this angle is naturally going to be 30 degrees. Now if you look at these two triangles, then this angle is also going to be 30 degree. Now these two sides are equal because these are sides of equilateral triangle, and these two sides are equal. This side is common side, and the angle between these two sides is 30 degree. So by side angle side congruency rule, these two triangles are congruent. So this portion will be equal to this. So we can say that this is x by 2, and this is also going to be x by 2. Now what you can do is, by applying Pythagoras theorem on any of these two triangles, you can find out this third side, which will be equal to √3 x by 2. And now if you take the ratios, let us take the ratio of 30, 60, 90, and these opposite sides. Side opposite to 30 degree is x by 2, side opposite to 60 degree is √3 x by 2, and side opposite to 90 degree is x. And now if you calculate this ratio, you just need to divide these 3 by x and then multiply by 2. So by dividing by x, we will get 1 by 2 ratio √3 by 2 ratio 1, and when we multiply them by 2, the ratio will be 1 ratio √3 ratio 2. This is the same result which I was talking about, and believe me, this result is going to be very, very useful for solving particularly multiple choice questions. Okay, and there is another rule, there is another triangle in which, let us say this is 90 degree angle, in which one angle is 45 degrees. So if this angle is 45 degrees, the other angle is also going to be 45 degrees, and this is an isosceles triangle. So if this is an isosceles triangle, the base angles are equal, so this is an isosceles triangle and the sides opposite to these angles are equal. So if it is a right triangle and isosceles right isosceles triangle, then the base angles are going to be 45 degrees each, and the sides opposite to those angles are going to be equal. So the ratio of sides in these kind of triangles will be 1:1:√2. Okay, how? Let us say if this is side x, so this side is also going to be x. What will be this third side? This will be x square plus x square under root, which will be 2x square under root, that is equal to √2 of x. So if you take the ratio x √2 and divide them by x, it will be 1:1:√2. So this ratio, whenever you see this ratio, you know that the angles are 45 degrees. Base angles are going to be 45 degrees. Alright, let's move to some questions. We will solve those questions by using SOHCAHTOA rule, as well as this. We will try and solve these questions by using these ratios which we have just derived. Okay, so let's move to questions now. Okay. In this question, height of a tower is √3 times of its shadow. The angle of elevation of the source of light is. Okay, let us say this is the tower that we are talking about, and this is the shadow. Let us say source of light is on this side. If the light will come like this, then the shadow will be here. This will be shadow, and this is the tower which we are talking about. Height of tower is √3 times of its shadow. So if the shadow is x, then the height of tower is going to be x √3. This information is provided in the question. This angle is 90 degree. We just need to find angle of elevation, and this is going to be angle of elevation of the source of light. So we need to find theta in this question. Now let us apply SOHCAHTOA rule. The sides which are involved in this question are, this is opposite side and adjacent side, this one. So opposite and adjacent side are in tangent. So tangent of theta is equal to opposite x √3 divided by x, which is equal to √3, and we know tangent of theta is equal to √3 when theta is equal to 60 degrees. So our choice will be B. But if you see, let us solve it by using the ratio which we were talking about, 1:√3:2, 30, 60, 90. Now if you see the ratio of tower and shadow, it is shadow and tower, it is given 1/√3. So we clearly know that the angle opposite to this side, that is the angle in question, theta, is going to be equal to 60 degree. So without solving this question, we could have said that the answer would be 60 degrees. Alright, so this is the use of this ratio. Okay, but you need not remember this if you cannot do it easily. Okay, if you find it difficult, then use SOHCAHTOA rule. Alright, let's move to next question. The angle of elevation of a top of a tower from a point at a distance of 100 meter from its foot is 60 degrees, then the height of tower is. Let us say this is the tower and this is the height which we need to find out, and there is a point 100 meters away from its foot, and angle of elevation of top of this tower from this foot is given as 60 degrees, and this is our right angle. We are supposed to find h, height of the tower. So let us see which ratio will apply here from our rule. We are again talking about opposite side and adjacent side. So tangent of theta will be the appropriate ratio. So tangent of 60 degree is opposite, which is h, divided by adjacent, that is 100. So h is going to be equal to 100 into value of tangent 60 degrees, which is root 3. So that is 100 root 3. So it is our answer. Now you see from our earlier method, this is again a 30, 60, 90 degree triangle, because if this angle is 60 degree, then the remaining angle will be 30 degree by using angle-sum property. And if the side opposite to 30 degree is 100, then the side opposite to 60 degree is going to be 100 root 3, because we need to maintain a ratio of 1 root 3 ratio 2, and naturally this side, which is not in question, is going to be 200. So this is 100 root 3 by using this ratio also. Okay, so let's move to next question. At any instant the shadow of a pole is equal to its height. The angle of elevation of the sun is, we know when the two sides are equal, then the angles are going to be 45 45 by our ratio, which was 1 ratio 1 ratio root 2, 45 45 and 90 degrees. So shadow of the pole and its height, if these two sides are equal, okay, this is pole and this is the shadow, and this is a 90 degree angle. So if these two sides are equal, then these angles are going to be 45 45 degrees. So this is our answer. Otherwise you could do SOHCAHTOA, tangent of 45 is equal to length of pole or height of pole divided by the length of shadow, and these two are equal, so the result will be 1, and this was theta. So tangent of theta will be equal to 1 when theta is equal to 45 degrees. So by using SOHCAHTOA rule as well as that ratio, we could have found the result. Okay. Then the question is, when the angle of elevation of sun is 30 degrees, now angle of elevation of sun is given. This angle is given 30 degrees. Let us say this is sun and this is the building, which is 50 meter high. this is the length of shadow which we have to find out. So first of all, let us do it by, okay, let's use Pandit Badri Prasad Har Bole also. Here we are involving perpendicular and base. So the ratio that we will use is tangent theta. So tangent of 30 degrees is equal to perpendicular divided by base. Tangent of 30 degree is 1 by root 3. It is equal to 50 upon x. So that will give us value of x as 50 root 3. So answer choice B is the correct option. Otherwise, if we use our ratio, and we know that the ratio of sides opposite to 30, 60 and 90 is going to be 1 root 3 ratio 2, and side opposite to 30 degree is given as 50. So side opposite to 60 degree will be equal to 50 root 3. Okay. A pole 6 meter high casts a shadow. There is a pole 6 meter high. It casts a shadow 2 root 3 meter long on the ground. Then the sun's elevation, this theta, is going to be. So again the two sides involved are perpendicular and base. So tangent of theta is equal to 6 by 2 root 3, which is equal to root 3, and theta will be equal to 60 degrees. And by using our ratio, 2 root 3 ratio 6 means 1 ratio root 3. Okay, if we cancel it out, like first of all 2 and then this one, so we will get 1 ratio root 3. So now the ratio is given 1 ratio root 3, and this is the side which corresponds to root 3. So this will be opposite to 60 degree. This will be opposite to 60 degree. So theta is going to be 60 degree. If the ratio of height of a tower and the length of its shadow on its ground is root 3 ratio 1, then the angle of elevation of sun. Now again, height of tower and length of shadow, the ratio is given as root 3 and 1, and we need to find this angle theta. Again we will do a tangent theta, which is equal to opposite by adjacent, that is root 3, which is opposite, and this is adjacent by 1. So theta will be equal to 60 degrees. Okay, and again by using that ratio also, we know that angle opposite to root 3 is going to be 60 degrees angle. So angle of elevation of sun is 60 degrees. Okay, thank you.